So this is the first problem of today's Div 2. And in this problem, we are given that there is a little boy, Nikita, and he's given some cubes and he decides that he'll build a tower using those cubes. Now, initially, the tower doesn't have any cubes. And in one move, Nikita either puts exactly one cube on the top of the tower or exactly removes one cube from the top of the tower. Now we need to find, is it possible that after n moves, the resulting tower has exactly m cubes? And n and m are both between 1 and 100. So let's look at this here. So we are given n and m, and both n and m are between 1 and 100. Now tell me one thing, if let's say we are given n moves and we need to have exactly m number of cubes in our tower, if n is less than n, the n is less than m, the answer is simply not possible, right? Yes, no. Okay. So let's say now n is like, for this, I think nobody should have any doubt. The answer is simply no. Now let's consider the case when n is more than or equals to m. So everybody agrees to this, that we'll first build, or Nikita will first build a tower of exactly m cubes, and then he'll go up and then come down, or like he can first go up, then down, then again go up like this. Now you might say, why first build a tower up till m? Why not like first build, let's say 3, then go down, then go up? So this is exactly the same thing. You are repeating this part, like you are removing this once and then keeping the cubes back. So this is like, you don't have to do it here. You can just first go up till m and then go up and then come down. Same thing. It doesn't matter where you are doing this, you first went up, then you went down, then again back up. So let's say this is the total m. So you repeated this much part, right? So this is the u that I'm saying, that you'll be removing these cubes. Same thing here. This is the m. You went up and then you came down. So this is the inverted u up till here. So this is what will be removed. So doesn't matter where I'm doing this. Now, the thing is, if you look at this, will always be of even length. Like the number of cubes that you removed or is simply equals to number of cubes that you have initially inserted more than m. Like after m, if you placed x on top, you are removing x. So exactly 2x are the number of moves that you are wasting, or not wasting, but utilizing here, right? You are using x moves to place the cubes and x moves to remove these. So total number of moves are 2x. So this is what we need. Now you can say, like, I'll do something like I'll go up till m, then I'll go I'll place some cubes, I'll remove them, then I'll again place them, then I'll again remove them. So in this case, if let's say you first placed x, then you removed x, then you again placed x, then you again removed x. So in that case, you'll get 4x moves. So again, a multiple of 2. So this is the lowest multiple. Like if you're seeing this factor, this is the smallest factor. So it will at least be something twice or something 4 times. So that's why it is always even. So if it is always even, finally, we knew one thing, that n is more than equals to m. So n minus m should be a multiple of 2. Is it clear? Now, either you can just check this, or you can check what I have done. I have just checked that parity of n is same as parity of m. Same thing. Why? If this is odd, this needs to be odd. If this is even, this needs to be even. Same thing as n minus m modulo 2 is 0. That is, this should be divisible by 2. Is it clear? N plus m also, you can write this also. N plus m should be divisible by 2. Same thing. Is it clear? Any of these would work. So is anyone having any doubt? Okay, clear. So let me show you the implementation. So this is the implementation. I've just taken the number of test cases as input. Then I have taken n and m as input. I'm checking two things. First of all, n should be more than or equals to m. And the second thing is that both should have same parity. If both of these conditions are true, I'll print yes, otherwise no. Any doubts in the implementation? Okay, so let's go to the next problem. So in this problem, we are given that we have a positive integer x, and we need to find any array of size n for which the following holds. The first condition is the size of this array should be between 1 and 32. The second is every value or every number in this array should be either 1, 0, or -1. The third is if the ith number in this is multiplied by 2 to the power I and all of these are summed up, it should be exactly equals to x. And the last condition is that there does not exist an index from 0 to like in the complete array, there doesn't exist an index such that that value and the next value is same. So let me first of all explain the problem. See, we are given x. Okay. And we need to find an array such that x is equals to sum of ai into 2 to the power I for I from 0 to n minus 1. And the next thing is node to ai is equals to z like non-zero, and ai plus 1 is also not equals to 0. This shouldn't exist. Like two adjacent places cannot be non-zero. And the third, what else like is the condition? Okay. And there is one more condition that ai is either 1, 0, or -1. Only these values. So first of all, forget about this problem. If I give you, let's see, if I give you, everybody here knows if I give you a value, let's say anything x, let's not say x, let's say alpha, you know, let's say this is in binary, it's 37. This is not binary, this is decimal. So everybody knows how we can find the value of this thing in binary representation, right? Everybody knows this, right? Like how to convert decimal to binary. So can like everyone just like quickly tell me what is the binary for this 37? Okay, this is the binary. Like this is the 0th bit, first, second, and like this way. When we are writing a binary, we go from this to this side. So this is the most significant bit, and this is the least significant bit, right? Right? Yes, no, everybody knows this. Now, if you were given that if you were given this exact problem, but this condition was not there, this condition was not present, then you could have simply printed this thing inverted. just print this thing inverted. Why? Why inverted? Because simply in the problem statement, we are given that a0 is being multiplied by 2 to the power 0. In this form, if we are writing 37 as like this, we are printing this thing with 2 to the power 0, this thing with 2 to the power 1, and this thing with 2 to the power 5. Hopefully, like everybody knows this. Like this is how we represent binary numbers. So if we have to satisfy like this problem, like this thing, this condition, then we should invert this. If this was not present, then this is our answer. Just invert binary representation. Is this thing making sense? Yes, no. Up till now, anyone having any doubt? Like, why is this the answer if this condition was not present? Okay. Now tell me, what is the condition that, let's say, our binary is this? Now, we know the answer is that we'll have to invert this. Invert. If we didn't had like consecutive two places having like non-zero values, we would have simply inverted and that was our answer. Like in this case, this is our answer. There is no two consecutive places that is having ones. But in case you are having ones, then let's look at a simple thing. What is the binary representation of 32? It is 1, 1, not 1, 1, 0, 0, 0, 0, right? This thing, right? This is the binary representation of 32. Now, what is the binary representation of 31? It is 1, 1, 1, 1, 1. Now, if you are given this thing and you have to remove, if you have to remove these consecutive ones, what you can do, you can place a 1 after the most significant bit, 1 here. All of these will become 0. Like, let's look at these two. This is 32 and this is 31. Let's write like 31. Please don't annotate, like, I don't know, like who did this? Like I'll disable. Like I don't know how many times I have to tell this, but like you are not here for experimenting. So I have 1, 1, 1, 1, and 1. And this is like there's, let's say there's a 0 here. We can assume that there's a 0 here. Okay. So if I have to somehow write this thing, but I don't want any two places to have consecutive like ones. So what I can do, I can write 32. And then in place of this, I can just simply write a -1. Why? Because in our problem, let's try to find the value of this. This is simply 2 to the power 5. This is 0, 0, 0, 0 minus like 2 to the power 5 into 1 and minus this 1 into 2 into 0. Same as 31. And you can do this for anything. Like if you have some zeros, then some ones, then some zeros, then some ones, like this. So I'm saying that this is the least significant bit currently. This is the most significant bit. So this is just for this block, keep a 1 here, replace all of these with zeros, replace this with -1. For this block, like I'm saying a block, if it is having more than or equals to 2 consecutive ones, just replace this with 1, 0, -1. You can check how. Let's say this is 2 to the power x, this is 2 to the power x plus 1, this is 2 to the power x plus 2, 2 to the power x plus 3, 2 to the power x plus 4. I'm just trying to prove like why this works. So this will give you something like 2 to the power x plus 2 to the power x plus 1 plus all the way up till 2 to the power x plus 4. And this thing is 2 to the power x plus 5 minus 2 to the power x. So if you know, you can break this down as this thing plus 2 to the power x, if you know. Like this is basically, if you, this thing is same as this thing. 2 to the power x plus 5. So if you subtracted 2 to the power x from it, you'll get this thing. So just find the binary representation. If you're getting consecutive zeros, replace the most significant, like whatever is after the most significant, replace it with 1, replace the next with zeros, and replace this with -1. Is this making sense?
Can you
This is
explain
not
again?
trial and error. This is like, if you know that, okay, you can break like consecutive ones like this. If you would have looked at 32 and 31, this is actually not trial and error. Like, there's a proof. I'll take a test case and then explain again. First of all, let me complete the logic. Like right now, we are not completely at the solution. Like, this is not what we want. Like, this is just breaking one block. But what if we have something like this? Now coming back. So this is the most significant bit, and this is the least significant bit. So if I break this block, I'll get a 1 here. So like this block is changing. So what you should do, you should always start with least significant bit and move from towards this. If you find consecutive ones, then break these, place a -1 here, 0 here, 0 here, 1 here, and remaining are same. Then this is the block that you'll get. Instead of just this block, this is the block. So replace this with -1, 0, 0, 0, and 1 here. 0, 0, -1. So can someone just quickly find what is the value of this? I want 2 people. Someone find the value of this and someone find the value of this. This is the least significant. Like this is basically 2 times 2 to the power 0 minus 0, 1, 2, 3. 2 to the power 3 minus 2 to the power 7. And this is 2 to the power 6 plus 2 to the power 5 plus 2 to the power 4 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. So both of these should be equal. Both are equal, right? So this is what we have done. Now ask me, like I'll take a let's take one test case and then I'll take your doubts. So let's take what, 27. So what is the binary representation of 27? Quickly. So 1. And we have this for 16. Then after this, 8. Then after this, 4. No. 2 and 1. This is the binary representation, right? Okay, this is the most significant bit. This is the least significant bit. Now, if you need to do like how to find the answer, let's start from here. This is a continuous block. Replace this with 1, 0, -1. The rest is same. This is a continuous block. Replace this with 1 here. Let's say this was 0. Replace these with 0, -1, 0, -1. Finally, you need to invert this. So -1, 0, -1, 0, 0, 1. This is your final answer. 2 to the power 0 minus 2 to the power 2 plus 2 to the power 5. You can check the value of this should be 27. And now, are we ensuring that our final answer array should be like less than or equal to 32, the size of array? Yes, because the element itself is not more than 10 to the power 9, which is, it is not more than 2 to the power 30. So even if you're keeping like after our final block, if you're increasing, like keeping our 1 bit after the most significant bit, our array size would be 31. Now you can ask your doubts. Like you can unmute yourself and ask your doubts. Is anyone having any doubt? Like, if you don't want to unmute yourself, you can write in the chat also. I'll show the implementation. If no one has doubt, we'll move to the implementation. Like, why not? Like, someone said, okay, so you wrote 0. Like, why are the last two places having, like, you are going wrong? If you started from this and then you first converted this, like I said, you need to start from least significant bit, not from most significant bit. Any other doubts? Okay, so let's move to the, if no one is having any doubt, I'll move to the implementation. Okay. N is maximum 32. So what do you mean by N is maximum 32? Like, size of array is 32, not the value itself. Like, I read this above, like you have mentioned it above also, but like I thought you would be able to figure it yourself. Array size is 32. If the value is like, if you have numbers between 1 and 2 to the power 30, the binary representation will be of at max 30. Why? You need only 30 bits to represent this number. So if you have numbers between 1 and 2 to the power 30, even if you're doing this kinds of operation, you will finally end up with the number of bits would be 31. So final answer or the array would be of size 31. So that's why. Why do you start from least significant bit and not most significant bit? Because the block that you're deciding here would change the block size that you'll get further. If you have this thing 11011 and you start from here, technically what you're doing, you're first doing this. So you'll write something like 1, 0, -1, and then you'll find this, and then you'll do on this and you'll get 1, 0, -1, 1, 0, -1. So this is, although the value of this, if you try to find the value of this would also be correct value only, because you didn't violated any rule. But the thing is, you got 2 consecutive ones. So that's why start from back. Even if in this case, you would be able to break those also. So that's why. Is it clear? I think I have answered all the questions. So let's go to the implementation. The implementation is simple, but it's a little verbal, so it seems long. So first we are taking X for every test case. Then I have declared this as, like I'm always saying that my array size, like the final answer would be of size 32 only. Then I'm starting from 29 and going up till 0. That is from most significant bit to least significant bit. Like this is one of the ways to find the binary representation. So why from 29 and not from 30? Because the value is less than 2 to the power 30. So the 30th bit will never be set. The value is less than 2 to the power 30. So the 30th bit itself won't be ever set. So how to find the binary representation? This is one of the ways. If the current bit, if the value is currently more than the current bit value, that is 2 to the power I, just set the bit and take modulo, that is subtract. If X, like if this value is more than, you could have written something like, if X is more than this thing 2 to the power I, then subtract 2 to the power I from X. Like, okay, I have a, like you have a doubt, like how did I come up with this? Like this, like I didn't, like I cannot tell you something new. Like I have solved problems like this. Like if you practice enough, so like solutions will come to you. Like there is no secret to that. Like I have like earlier also, like many times answered the same question. So that's why I don't answer this kinds of thing. Like how was I able to come up with solution? Like there was no, like I during the contest there was no nothing like I was able to find myself, and then the solution came to me. If you want to hear that kind of story, like, sorry, I don't have that kind of story. That I was singing for 30 minutes and then something, it, like I was able to relate this from my past, that okay, this happened to me, and then I was able to come to the solution. No, I have solved many problems like this. And when I looked at this problem, like usually like I don't have to think that much, like, and I don't know like how this came to me, but yes, I was able, because the simple thing is I have practiced enough. That's the only thing. Like if you practice enough, you'll be able to solve. So that's why I didn't take your like doubt. Okay. So coming back to this, once I have the binary representation, then what I can do, I'm trying to break the blocks and I'm starting from the least significant bit. If the current bit is zero, like if the current bit is zero, it's like I don't have to do anything. Otherwise, if the current bit is one, I'm trying to find, like I'm trying to get the block size. Like what is the block size? So I'm going till from like from I, I'm starting my block and I'm going till wherever my current bit is, like the bit is one. So using this J. And while I'm going to those, I'm also making those as zero. Why? Because finally I want the first, like the most significant bit after, like the bit which is after most significant bit to be one, and currently I should be -1. So in between everything should be zero. Then finally, this is the check. Why? If the current block size is more than one, that is, it should be, if it is just one, you don't have to do anything. Like if it's just one, you are doing this thing. If you, like if it's just one, like you have something like this, then this is your I. Let's say this is the least significant bit. This is the most significant bit. I've inverted the terminology which I was using here in the above, like for binary representation. So otherwise, if I'm not checking if the size is more than one, then what I'll do, I'll place a -1 here and one here. So although the value is still correct, like even if you will do this, although the value, like the total sum will still be equals to X, but you have violated the rule that two consecutive places shouldn't have more than, like shouldn't have non-zero values. So that's why you need to check that the size is more than one. And then if it is, at J, keep a one, and at I, keep a -1. Finally, your I will become J. So from I to J, you had a consecutive block which was having consecutive ones. Finally, I'm printing the size of my array and I'm printing my array values. Is it clear? Okay, like again, same thing. Like I don't know what would be the rating of this problem. Like pretty, like it would be around 1,000 only. Like if I have to guess, but again, I'm not sure. Like it depends, like how many people were able to solve, and on like I am pretty clueless. Like what would be the rating of this if I like close to 1,000. So let's go to C. So in this, we are given that Nikita is a student passionate about number theory and algorithms, and he faces an interesting problem related to array of numbers. Suppose Nikita has an array of integers a of length n. Then he calls a subsequence of array special if its LCM is not contained in A. So LCM of an empty subsequence is equals to 0. Now, Nikita wonders what is the length of the longest special subsequence of A, and we need to help find him the answer. So the only thing that in this problem is interesting is n is between 1 and 2000, and the values are between 1 and 10 to the power 9. So, and one more thing, it's guaranteed that the sum of n over all test cases does not exceed 2000. So we can have something like n square approach. So first of all, let's discuss what we have to do. We're given an array and we need to find the longest subsequence. Whose LCM, whose elements LCM is not in array. Now, like when I started solving this problem first, like when I read this problem, I knew like it could have like it might be some DP problem, but since like I was seeing some like I was like this is a maths problem if you have to keep this in like one of the buckets. So I started like instead of like I try to avoid DP usually. So I gave it like around 10 to 15 minutes. I was able to come up to a solution. But then when I started to write that solution, I was like, pretty much convinced that DP solution would be easier. And I didn't have to think that much. Like I would say it's not DP, but it's brute force only because the constraints are so low. So instead of writing that solution, I wrote a DP solution. It's not DP, it's kind of brute force only. Very basic, very easy, you'll understand it. But in case anyone wants a solution that has like that uses maths logic, like if you have to just maths, like if there are like the things like if there are n numbers and if you if you are finding the LCM, then if the LCM is not present, that means like if LCM can be like there are only n numbers, n unique, n there can be at max n unique numbers. So you can keep these in a set, and then you can use like that set to find whether the LCM is in the array or not. But I have not done that. And if you want that, you can like probably I'll discuss like I'll not take that in this session, but if you want, I can share that solution with you guys, maybe on the Discord, or I'll like if you want if you want that to be discussed, probably raise a query or tag me in it. But I'll share the solution, okay? Like I'll have to first implement that. So that's why I cannot show you right now because I haven't implemented it. I have to implement it. I'll implement it once the system testing ends, and if it gets accepted, I'll share that. I'm pretty confident that it'll also get accepted. So coming back to this now, how did I solve this using DP? So first of all, this is clear to everyone, right? What we have to do and what we are given. The problem is very straightforward. Now, first of all, let's look at one thing. There are n numbers. If I find LCM of all of these, like our first thing should be like our first motive should be if we take LCM of two numbers, x and y, can you comment something about z? Let's say LCM of x and y is z. Can you comment about one thing? Z will always be more than maximum of x and y. Like I'm not that is also true, but in that case, you have to like it should be there should be a like you should be you should be knowing whether x is more than y is z. But I don't have those constraints. So this is yes. Everything that you have written is true. Z should be divisible by x and y. Z is equals to multiple of x and y divided by GCD of x and y. So now, if we have this thing, so our best get one of the best ways to guess is like let's try to get if all like what is the LCM of all of these? If my LCM of all of these is more than the maximum in this, LCM of all is simply more than maximum of all, my answer is n. The subsequent size will be n. I'm taking all the numbers, right? Yes, no. So the first thing that we can do, you don't have to do this, but this simply avoids our like unnecessary computations. So find LCM of all and check whether it's more than, it is more than the max or not. If so, then your answer is M. Now, this is not just helping us here. Like, it's not just reducing the number of competitions, it's also reducing, like, one thing I know that now whatever LCM, whatever subsequence I choose, its LCM will be less than or equals to 10 to the power 9. Can someone tell me why? Why I can claim this? That if this condition is not true, then whatever subsequence I choose, its LCM will always be less than or equals to 10 to the power 9. Right? Why? Because I have taken like I said, if you are taking LCM of two numbers, the value can be more or equal only. So if I take LCM of all, it is going to be more than or equals to all the numbers, like all the possible subsequences LCM. So if this is not, it equals to maximum, and maximum itself is not more than 10 to the power 9. Like maximum is less than 10 to the power 9. If this is not true, then our LCM is less than or equals to max. It won't be less. It would be equal only. Again, like I don't think anybody would be having doubt. If this is not the case, LCM is not more, it would be equal only. Why? Because that max element is actually included while taking the LCM. So LCM is equals to maximum, and this maximum is less than 10 to the power 9. So that's why our LCM of any subsequence will be less than or equals to 10 to the power 9. Now, how does this help? Now, first of all, if there are n numbers, and if I can get something like, what is the LCM, comma, what is the size of sequence? Now, what can you claim about this? How many LCMs can they be? Like LCMs can be many, right? There can be 10 to the power 9. But what can be the size of sequence? What can be the size of sequence? Size of sequence can be at max n. So now let's try to look for this. There can be at max n sequence sizes, right? Yes, no. So I just need to map these two things. Let's say there is one way to what we can like we can either use, and there is one more thing. If there is, if you are getting 7 as the LCM using a sequence 1, like let's say you are getting 6 as the LCM, and there is one sequence which is just having 6. There is another sequence which is having 2 and 3, and there is another sequence which is having 1, 2, 3, and 6. Which sequence will you choose? Which subsequence will you choose out of these three? You'll choose first, second, third. Max length, right? This one. Why? Because you have to find the subsequence which is having maximum length. So if you're getting the same LCM, you should use the maximum length. Now, only this much information is enough to find the solution. How? First of all, we know that the size of sequence should be maximized. We need something like LCM to map to be size of sequence, and we need this should be maximized. So let's try to make a DP, and this is a map. Why map? I'll explain this in a moment, but this will give us for this LCM, what is the max size up till now. So what we can do, initially DP of, like what is the LCM? Initially the LCM, let's say for just for calculation purposes, let's say we are getting LCM as 1 for size 0. Why? Because later on we'll use this LCM. Like we'll use this one. So this is like in the problem, it's given that LCM of size 0 is 0. But this is just my base case that LCM for size 0 is 1. Okay. Then because 1 and any x, LCM is x. So that's why I'm using 1, not 0. I'm not sure if you do zero, like in C++, I'm not sure in other languages also, what is LCM of 0 and something else. It should be, it can be 0. I'm not sure if it is calculated like X into Y upon GCD. Like I'm pretty sure that GCD of 0 and X is X. But I think LCM should also be X, but I'm not sure. But anyway, I used DP of 0 as 1. If you're getting DP of like, if you're getting LCM of 0 as 0, you can use 0 also. So this is the LCM. This is the size, currently maximum size. So now what you can do, you can iterate through all the n elements one by one, create a new DP array. And new DP is initially like, what is this new DP? New DP is just a DP, simply a map. And in this new DP, like what I'll do, I'll iterate through for all values of LCM and sizes. I'll try to include currently, let's say, okay, like first of all, my state is clear to everyone, right? DP of LCM is equals to the max subsequence length. This is my DP state. Is this thing clear? Is this thing clear? Now let's come to the transitions. Now I'll iterate through all my elements. And for every iteration, I'll create a new DP array. And in this new DP, what I'll do, I'll iterate through all the LCMs and the sizes in my DP. Like DP is a map, right? Like I said, DP is a map. This LCM is having this much maximum subsequence length. And I'll include this in my new DP. New DP for this much size. I'm including this AIth element, right? So how should I write this? Like DP is not of size, DP is of LCM. So LCM of AI and whatever the LCM was here, let's call this LCM dash. This is the LCM value of initially of this much size. Like for this much LCM, you're getting this much maximum size. So this LCM dash, LCM of this is equals to like whatever the LCM of this value is, maximum of whatever this is, same, comma, can someone tell me what should come here? Anyone? Anyone? Like size plus 1, yes. Maximum of whatever the value is here or size plus 1. Because this is the same size in this size. This is the maximum size of subsequence you are getting for this LCM. If you take AI and include this in subsequence, you'll get the new LCM as this thing. And its size would be either the maximum of whatever is currently stored in this or this size plus 1. Finally, once you have done this for all LCM and sizes, this new DP is assigned to DP. This is basically why I have done this, like why I'm doing this. Instead of doing a 2D DP array, you can have a 2D DP array. Like instead of having this DP, you can have another state added here, N, for all the N iterations. But you don't need that. This is called space optimization. So I have just used two 1D DP arrays. If you have two 1D DP arrays instead of one 2D DP array. So I think this would have been taught if DP is covered. So finally, we can print what? What do we need to print? Finally, DP will iterate through DP. In this DP, I have everything. I have LCM and I have sizes. So for this LCM, what is the maximum size of subsequence I'm getting? So for these LCM, I'll try to find in my array. I can like insert all the values of my array in a set and I can check whether that set is having this LCM or not. Basically checking in my array, this value is contained or not. If not, my answer will be maximum of answer comma size. Is this clear? Yes, no. Recursive solution is also the same, that like in this, like there is like no point because like recursive solution, you'll be iterating over this thing, right? So technically, there is no point in writing a a recursive solution if you're iterating through your array. Any other doubts? Upper bound for LCM's count, what would it be? Like, first of all, I'm not counting LCM counts. I'm counting having the size. And what is the size? N. Maximum size will be N, not more than that. Like, why would it give MLE? In this, what is the size of this at max? What is the size of this? How many times am I iterating? 2000. Like, what is the size of DP? Maximum 2000. So why would it give TL, MLE? N only. Like, just look at this. In every element, I'm just having that initially there was just one value, this. And then I iterated. If my DP is having some LCM, then LCM and some size. So take new LCM and update the new DP if I am getting more size. So for each element, there is at max one more entry being added. So N. So why would it give MLE? Again, like I don't know what would be the rating. It would be around 1600, I would say. 1500, 1600. Okay, so now let's look at the implementation. The implementation for this, like I have always said, the implementation will be small, but it would be a little complex. Like understanding the DP solution as it is a little difficult. So first of all, I have taken N as input, then I've taken the array A as input. Then this is just for checking whether like this part is simply checking that if the LCM is more than the maximum element. So how? Find the maximum element, find the LCM of all. If at any point you find that X is more than maximum, simply print the answer, mark this. This is my check. Like I don't have to compute this. If I have found my answer here, so simply F as I'm marking F as 1, and I'm like this continue loop will go to the next test case. You have to check it here. You cannot check afterwards because it's possible that your LCM is more than 10 to the power 18 or anything more than it. Like it can be far, far, far more big. So just check for X is more than maximum. And as soon as it's big, just break it. Now this is my DP. I have two DP arrays, DP1 and DP2. This is my new DP. For first DP of this LCM, I'm saying this is the size, maximum subsequent size. Then for every element, I'm iterating through this X is my LCM, Y is my size. I'm calculating the new LCM. I'm saying DP2 of this new LCM is maximum of DP2 of this LCM and size plus 1. Finally, after this, I'll update my DP as DP2. Now, then I'm setting my answer as 0. And this is my set AA, which is nothing but all of these elements. Then I'm iterating through my DP. If X is not present in this set, I'm saying my answer is maximum of answer or this size, whatever the maximum size of subsequence I'm getting for this LCM. Finally, I can print my answer. Is it clear? Okay, so that's it for today. Thanks for joining. Bye-bye.